got confused about 18.
Okay, you're going to have to give me the specifics.
Okay, it's the system response when it's pulled up.
But describe it for me.
So let's see, we have a system that takes x of t.
Hold on. This is problem 218?
Yeah.
I got the filter. I just don't like references.
Yeah. Yeah, sorry, it's 81.
Uh, 218. It's got the H. It's got that series thing.
Yeah.
All right. Let me just draw it up there. This is something that's kind of intuitive. They have a block like this, right? Then they have a summer here. The output. Here, I can, if you just tell me, I think I can get it. I don't like holding the book.
From the left, I'm going to start. And it's going to go, I'm going to go left, and then I'll start to go to the top. H1 of T,
Give me
H2
1
of
second, just let me get the arrows.
Okay.
I'm going to just tell you one tip. Show the direction of the signal flow always with arrows. You can hurt yourself if you don't. Remember that. Now here, is this X of T here?
Yes, sir.
And is this H1?
Yes, sir.
And this?
2.
H2?
Yes, sir. 3.
And this
4.
4? And they want the output?
Y of T.
All right. Now, anytime you have a signal in general into a block like that, let me just show you something. And you'll get this in a second. If you have an input, I'll call it X of T, and an impulse response, H of T. All these H's here indicate the impulse response of the system. Are you with me? Anytime that occurs, the output here, Y of T, is simply the convolution of these two. It's X of T convolved with H of T. Which means, if you listen to me here, let's go through this path, the upper one. You'll see this in a second. It's very intuitive. Follow me. Don't write, just watch. You come up here, the output at this point is simply going to be X convolved with H1. I'm not even going to put this T in there. Are you with me? Everybody see that? Now that is going to be the input of H2, which means this output at this point is going to be X convolved here with H1, and that whole thing convolved with H2. I'm going to show you a property of the actual impulse or the convolution in a second. It'll make this simple. You all understand that? How many do? Show of hands. All right, down here you do the same thing. At this point, you have simply X convolved with H3. My 3 is pathetic, but H3, right? Now here, what do you have? You're going to have H4 convolved with this. X, right, convolved with H3. Everybody agree with that? How many see this? It's very intuitive. This is a summer. It's a mathematical statement. It doesn't. I'll show you in a while how you actually do that electronically with op amps. But what you're doing is taking this signal and adding it to this signal. That's all you're doing. Follow me? So now the output here is going to be this output, which is H2 convolved with H1 convolved with X, plus H4 convolved with H3 convolved with X. And that's the output. You all see that? Now here's some properties of convolution I didn't go through. They're shown in the book and they're easy to prove. Well, I said they're relatively easy to prove. First one I said before. X convolved with H is the same thing as H convolved with X. The order makes no difference. Understand? Now, if you have X1 convolved here with X2 convolved with H1. Follow me? You can do, basically, this is the same thing as X2 convolved with X1 convolved with H1. The order that you do these doesn't matter. You could put this is h1, this is x2, and this is x1. The order doesn't matter in convolutions. Does everybody understand that? So it doesn't matter how you switch them up. So in fact, for this one, you could take x out of here. You could say it's x convolved with, and then you could say h1 plus, or h1 convolved with h2, you'll see what I'm doing, plus h3, pardon me, convolved with h4. Does everybody see I factored out x from the top one? And whatever remained, I convolved those first and then convolved the remainder with x. With me? That's the point of this. Now, I don't know what the question was in there, but I think that hopefully answers it. Was there a secondary part to that?
It just asks to show, it gives you impulse, or it gives you the impulse response for each
All right.
H or T, and it asks you to show that the whole system impulse
We'll do it.
response is
Well, I
zero.
think we can do this fairly quickly. Do me a favor. What's x?
It doesn't provide X for you. I don't think you actually need it to.
It doesn't give x?
No, it says show the overall impulse response of the interconnected system shown in the figure is h of t equals 0. And then it says the impulse responses of the individual systems are, and then it gives you...
Wait. H of t is 0.
Yes.
Oh, the overall impulse response is 0?
Yeah,
All right.
you're showing
Wait,
that.
the
Sorry.
overall impulse response is 0, right? That means this is an impulse. If you have an impulse response, the input's an impulse. That's what it means. Understand? So they want to say if you put an impulse in here, your output is 0. That's what they're looking for. All right, now you can give me what each one of these is. Is it by a picture here or mathematically?
It's listed in a formula.
All right, what is h1?
E to the negative t u of t
Uh-huh.
minus e to the negative 2t u of t.
U of t?
Yes, sir.
That is just look at this right here. This functional form, this is an oddity. What it really is this. E to the minus t minus e to the minus 2t times u of t. Follow me? Now, if you think about that, you could pull an e to the minus t out in front, couldn't you? And if you do that, you have e to the minus t times 1 minus e to the minus t u of t. All right, that's h1. What is h2?
E to the negative 3t ut.
Uh-huh.
And then now it's h3 of t.
H3?
Yes, sir. It's e to the negative 3t u of t minus e to the negative 2t u of t.
Okay, go ahead. And I'm going to break this up. I'm going to take e to the minus 2t out. So it's e to the minus t minus 1 u of t here is h3. You all see what I'm doing here? I'm trying to break it down so when we do convolution it'll be fairly obvious why it's here. Next.
H4 is e to the negative t u of t.
E to the minus what?
Negative t to the u of t.
Just u of t?
Yes, sir.
All right. Now for these, remember the property of convolution I told you about. So, when I look at this, H1 convolved H2 is what I'm worried about. I got H1 right here convolved with H2. Now, I'm going to just show you this for a second. H2 has got less going on. Trust me. H2 is just a straight exponential decay, right? H1 actually has got something going on where it's going to go to a peak and then it's going to head to a relative maximum and go to minimum. I'm going to show you what it looks like. When I take this as the one I don't flip and I put it versus tau, and I have H1 of tau here. What that actually is e to the minus tau times 1 minus e to the minus tau here, u of tau, or it's only good for tau greater than 0. It looks like this. Follow me? That's what that looks like. It goes to a relative maximum and dies to 0. It starts at 0. Now, when I take the second one, H2, and I flip and shift, if you've done your work, you know what I mean by that. Are you with me, class? If I look at e to the minus 3t, it's a decaying exponential. When I flip it, it's a decaying exponential in the negative t direction. Do you all understand that? And then when I add that offset, I get this. Now I'm going to have this. This is the equation for this here. Now this is going to look like this. The equation for this is e to the minus 3, and now it's t minus tau, u of t minus tau. Are you with me, class? Please watch that. How many see this right here? Y'all see it? How many see it? Do you understand what I'm doing? Do you understand? Yeah. You don't understand? Okay. Were you here for class last time? All right. You remember where I said you took the functional form, if we just took e to the minus 3t, this form right here, and plot it versus tau, it would look like this. This would be e to the minus 3 tau u of tau, correct? Now, if you flip it, it does this. This is equal to h2 of tau. When you flip it and you put h of 2 of minus tau, it looks like this, right? The opposite way. Are you with me? Now when you add t to it, because the definition of convolution, in case you forgot, I have this, I'm assuming everybody knows by now. Y of t, if it's equal to x of t convolved with h of t, y of t's, the convolution, the definition of this, is the integral from minus infinity to infinity of x of tau times h of t minus tau d tau. The order of these functions doesn't matter. So you'll always find the one that's got the most going on and you put it as x of tau. You don't want to flip that one. It's got too much going on. Then you see the other one that has not as much going on, and you first flip that, in other words, make it h of minus tau, and then you add t to that argument, and it draws the curtain over to the right. Are you with me? If you've done this should ring bells. This should make perfect sense. How many see that right there? All right. I mean, please do your homework or you'll fail. I can only tell you that from experience. I've taught this course too many times. Now look here for a second. For t less than 0, there is no overlap. Do you agree with me? Everybody? All right. For t greater than 0, the overlap is from t to here. Or really what I need to do is multiply this function by this function right there. You with me? How many see that? Then I integrate. So when I multiply these two functions together, take a look at what I get. I get this times this, right? And I'm going to write it down here. So now I get e to the minus 3t times e to the 3 tau. That's this right here, correct, class? And I multiply that times that. And then I get what? I get e to the minus tau here times 1 minus e to the minus tau. And that's really what's going to happen. That's going to be my function that I'm going to integrate. That's the product of these two. That's x of tau times h of t minus tau. Now look, when you do the product of these, you can see one thing. The e to the minus 3t isn't going to be part of the integration with respect to tau. Do you all see that? I won't fly through this part. Do you see it over there? Can you all see it? Can you see it there? Let me break it out right here for this. So if I take a look at this, and now I'm going to get my y of t being the convolution. That's the integral from 0 to t, and I leave e to the minus 3t out in front. Let me put it right out in front here. E to the minus 3t. See that? And we'll leave it out. Then I have this times this, which is going to be e to the 2 tau, right? So I have e to the 2 tau. And then I have this times this, which is going to be this times this, which is e to the minus 2 tau times e to the 3 tau, or simply minus e to the tau. Do you all agree with me there? How many say this? Were you doing it this way?
I tried it.
I mean, do you understand what I'm doing? Were you doing it? Are you following my steps? And it's going to be d tau, correct? Do you agree with me? Everybody with me? Now, we're going to do that integration in a second. But now we're going to set up the second one. First, before we can do this integral if you want, what does it come out to? Just look at this. That one would be y of t. That would be this part right here that we're going to add to this part. Y of t would be equal to what? E to the minus 3t, right? Integrate e to the 2 tau d tau. 1 over 2, right? 1/2 e to the 2 tau, right? Evaluated from t to 0, correct? So that means it's going to be 1/2 for the first one, and then it's going to be e to the 2 tau from 0 to t is e to the quantity, I'll just put 2 tau here, from 0 to t. That's the first part, and it's going to be minus, when you integrate e to the tau, you get e to the tau, evaluated from 0 to t. It's just going to be e to the tau, evaluated from 0 to t. That goes down here. Are you with me so far, class? I know we're getting to the nitty-gritty. Are you with me? Everybody?
Yes.
It's straightforward at this point. Now I got e to the minus 3t here. And then I have, when I evaluate the first part, it's 1/2, and it's e to the 2t minus 1, minus, and this is going to be quantity e to the t here, minus 1. Remember, there's a 1/2 in that, and that's what that part is. Are you with me? Now you go to the second part here. I'm going to use this part of the board for it. You picked a good one, I'll say that. Now the second one, we have H3, which is given by that, and then we have H4. H4 has the least going on. Do you agree with that, class? Everybody with me? So I'm just going to graph that versus tau. And when I do that, I get this. That's the one I'm not going to flip. It's going to be H4. I'm sorry. H3 is the one I'm not going to flip. H4 is the one I'm going to flip. It has this going on. I'm sorry I said that way. So H3 is going to be left alone. And that one looks like this as well. Something like that. It basically doesn't, it asymptotically goes to 0. This is versus tau. This is going to be H3 here of tau. And that equals e to the minus 2 tau times the quantity e to the minus tau minus 1, right? And that's it for tau greater than 0. And then I take this one and I flip it and I shift it. And I should get this. My H4 t minus tau looks like this. And the equation for this is e to the minus quantity t minus tau, and it stops at t. Do you agree with that, class? Give me a show of hands if you do. You see it? Down there? I want to make sure. Now, this is one of these things that you can easily get bored and lose focus with when you're doing this problem. I warn you, don't. It's easy to mess these up and easy to fail this course. It's important that you be attentive to all the details. Not casually just say, oh, I'll get partial credit. You won't. Not with these. You have to be very exact. Now, when you take a look at the area of overlap, you all see it's this and this. So now I have to multiply this function times this function in the area of overlap and integrate it. Don't I, class? Because convolution says it's the integral, the multiplicative product of those two things over the area that they're not, neither one's 0. So when we do that, what do we get? Well, the equation for this is just what, right here? It's just e to the minus t times e to the tau. Isn't it right here, guys, for where I've shown? You all see that there? Here, what I've got that. So when I multiply this times this, what do I get? When I take a look at h3 of tau times h3 of tau times h4 of t minus tau, now I get, I'll take this one first. I have e to the minus t times e to the tau times e to the minus 2 tau, right? Times e to the minus tau minus 1. Correct, class? With me? I didn't integrate it yet. I'm just going to try to settle this thing, make it a little easier. So this looks like e to the minus t times the quantity. You'll notice e to the tau times e to the minus 2 tau is e to the minus tau, right? Times e to the minus tau is e to the minus 2 tau, correct? And then e to the tau times e to the minus 2 tau is e to the minus tau times 1 is e to the minus tau. Agreed? Everybody? And then we integrate. Don't lose focus here. So when we integrate it, we have to integrate this from 0 to t d tau. That means we can pull the e to the minus t out in front. And what do you get? E to the minus 2 tau integrated is minus, right? 1/2 e to the minus 2 tau from 0 to t, correct, class? I'll just put it there, e to the minus 2 tau from 0 to t. What about the second part? That's minus, but it's e to the minus tau, so it's going to be plus, isn't it? E to the minus tau integrated from 0 to t, or evaluated from 0 to t, and that would be it. Do you agree, class? I know I'm cramming myself here. Are you with me? Can you see, Jeff? You're squinting. You want me to draw bigger? I'll try.
No, it's not.
Can you see in the back? Okay. I'm just making sure. Now I get down this point and I do the evaluation. What do you get? Let me put the evaluation over here. Block it out. Well, what do you get? The e to the minus t stays out there, doesn't it, class? Right? How about the first part? I got minus 1/2 times that. Notice anytime you get a minus sign, the best thing to do is change the limits. With me? Just change the limits. So I can make that plus, make this t, make this 0. In that case, what is it? It's what? Well, 1/2 for sure. Do you agree with that? Next, what is it? E to the 0 is 1, right? It's 1 minus e to the minus 2t is e to the minus 2t, right? I've got that, and then I got the last part right here. What is this going to be? It's plus what? E to the minus t, right? Minus 1. Y'all agree with that, class? Take a careful look. Do y'all agree with me? It's a little troublesome going through all that. But how many see this? Now look at the final form. You see e to the minus, we got to add this, right, to this, correct? Don't we? And it says it's 0. Well,
Yeah, it shouldn't be
I thought
zero.
it said equal exclamation 0, so would that be not equal?
I'm sorry.
For the question, I thought it was saying prove that it was equal exclamation mark 0. I don't know what
No, it says the impulse of the impulse response of the internet system is h of t is equal to 0 exclamation mark.
That's 0 factorial. Or 0, he means, oh, wow.
Yes.
It's 0. I think he means, oh, not factorial. All right, now, the funny thing is, if you look at this, and I'm not sure the easy way to do this, this should have a 3t if it's exactly 0, because this is the negative of that. If you look at this, see this right here? This is this, only it's a negative. You all see that? Now look at this, it's exactly the negative of that, isn't it? Are you with me? When you add them together? The problem is, you got e to the minus t here, and e to the minus 3t there, unless I bungled something, and now I'm starting to concern myself with that. Oh, that's a 3t, right? Isn't that minus 3t there?
Yes.
In the solutions, does he show how he did this? He might have bungled it himself. Because I see an e to the minus 3t there, and I see an e to the minus t here, and that's different.
The exponents are flipped as well, so...
What's that?
The exponents are negative in one and positive in the other, and so when you end up multiplying it all together, it does in fact cancel out.
Well, that's not
Yeah, on
multiply.
eight-
You add them. That's an adder.
On H,
Yes, when you integrate it, the negative signs, when you multiply them together with the negative, e to the negative t on the outside, that's going to make the negative 3t negative 2t.
You're right. You know what? You're absolutely right, because when you multiply through there, you are going to get. Who are you? Yes, you are. Yes, you are. It is going to be 0. You're right. Who said that? You're right. It is 0. I'm sorry. I didn't multiply this whole thing out, but if you do, this times this is e to the minus t, which is right here, which is times 1. It does cancel. My bad. I didn't see that. You all see that, class? If you multiply everything out with t, you're going to see it's 0. Go ahead and do it. I promise you. That's a long one. I didn't mean to take that much time, but it was worth it. The convolution is the big thing I'm worried about today. Are there other convolution questions? I want to get to those, please.
2.14.
Thank you. Thank you for noticing that. I always look where there's an exact symmetry for cancellation, and I didn't do the multiply thing out. But that's how you do that problem. It's a good problem. All right, go ahead. Next one.
So you have two functions. One is sine of pi t
Okay,
from 0 to 1.
Let me call it x of t
Yes.
equals sine of pi t, good from t greater than 0, less than 1.
Yes.
Okay?
And
What problem is this, by the way?
14. It might be a little easier if you read it the way it has in the book for us to understand. Because it says for functions x of t and h of t are given by, and then it's x of t is equal to 3 different things.
All right, but I want to do one at a time.
Okay.
This is the first x of t, right? What's h of t?
h of t is u of t.
All right. And it wants it convolved? Is that right? All right, these are easy to do. Now I'm going to tell you, y'all see sine changes a lot? U of t doesn't? Show of hands here, how many know that? U of t is just either on or it's off. So the one I'm going to flip is u of t. I'm leaving that alone. So I graph it versus tau. Now please watch this. So I take a look at this. It's 0 except in this range, right? Is that right? All right, so what it looks like is this. When I look at a sine wave between 0 and 1, if I call this 1 here, and this is now tau, and I'm graphing sine of pi tau, right? So what is the sine of pi? It's the sine of 180 degrees, right? Which is 0, correct? So it looks like this. And this would be 1/2 here. And this is the sine of pi tau. And it's only valid for tau greater than 0, greater than or equal to, less than or equal to 1. Right? Now take the other function, u of t, and make it u of minus tau, right? And then add the t to it, so it's u of t minus tau. And when I look at u of t minus tau versus tau, it looks like this. Now you can see something happening. This is only going to have overlap for t greater than 0. Do you all see that? How many see that right there? So we know what the value range is for t greater than 0, but the integration will have there'll be two different regimes. From 0 to t equals 1, it will just be integrating this area, but for t greater than 1, it will become a constant. Do you all see this? Everybody? And if you can't read my writing or I need to write bigger, let me know. I like comments so I can help. So now I can say for t here, greater than or equal to 0, less than or equal to 1, my convolution of these two functions, and I'm just going to say y of t convolve x of t convolved with h of t will simply be y of t equals the integral from 0 to t of sine of pi tau d tau, correct? And then we'll finish that integration in a second. And for t greater than 1, y of t will simply be equal to the integral from 0 to 1 of sine of pi tau d tau. And for t less than 0, the convolution will simply be 0. Do you all agree with that? Agree? T less than 0, there's no overlap, it's 0. Right? T greater than 1, it's a constant because we got all the area. Are you with me? So here's the one, let's just evaluate that. What's the integral of sine pi tau d tau, or sine x, sine pi x dx? It's what? Minus, right? It's minus 1 over Say it. Pi, right? It's 1 over 8, 1 over the constant, right? Times what? Cosine of pi tau, evaluated from 0 to t. Now, I told you this a second ago. When I see that minus sign there, I just flip the limits and get rid of it. Does everybody know why I'm doing that? I flip the limits right here, and I get rid of the sign. So this becomes 0, and this becomes t. Which means this is simply 1 over pi, right? What's the cosine of 0? 1 minus cosine of pi t. Are you in agreement with me? For the second part, this one, I should say for the second time regime, for t greater than 1, what is this going to be? Just this with t equal to 1, right? Do you agree with me? Right? We still do the same integration, only now t is 1. Well, what happens? I have 1 minus the cosine of pi, right? It's the cosine of pi. Cosine of pi is minus 1, isn't it? Correct, class? It's the cosine of 180 degrees is minus 1, right? So I have 1 minus a minus 1, or 2 over pi. And that should be it. I hope that answers your question, sir.
Yeah. I don't know, maybe I was just reading, well, I get what you've got up there. The problem is, in the solution, it looks like it continues to be periodic even after.
Well, hold on. Now, if this is true for all time, it's different. I thought it was only from 0.
It is, and so that's.
Oh, it is for all time.
That's what. No, it's only for 0 to 1, and so I drew the conclusion that you did, but the book has a different
That's wrong.
solution.
The only time you're going to get that kind of oscillating solution if the sign goes on forever. There's
Okay.
probably a grad student that did it and messed it up. Seriously. Y'all with me on this, class? That's how you do it. If this, in fact, represents correctly the functional forms, then it's a constant after 1. You're right. Okay. Any other ones? Convolution now. There's a lot of tough ones. I mean, there's some wild ones. I can come up with a few that'll drive you nuts. Nobody? Did y'all do them? I gave you some hard ones, right? Yes, sir.
It's the first one, t plus 1, 0,
Okay, hold on. Some of these are really, they're tedious. And it's one of them things you got to look for everything. Go ahead. Which one is it? 2 point?
1, 0.
All right. Part A.
So it has 2 graphs. The first one's going to be, they're both going to be like a square, but the first one's going to have A is 1, and then 2 rows will be in 2 seconds.
Okay, hold on. So for this one, this is T1, and this is height A, right? And I'll call that X. And for the second one, call that H, I have this. And it's height B, and it goes out to T2, right?
Yes, sir.
And then I want to convolve those twos. Now, I'm going to tell you something about convolution you'll like. Anytime you have 2 signals that have a finite duration where they're non-zero, and then 0 after that, the width of the convolved function will be the sum of the widths of this plus this one. So the total width you're going to get is going to have T1 plus T2. Will be the total width. Understand? It'll go from 0 to T1 plus T2, or really have a dimensional width of T1 plus T2. This is very important. Now, when you do convolution, these are the easy ones. I mean, they're both basically the same, aren't they? They both, I mean, I guess you should know if T1 is greater than T2. For part, you want to give me part A? Did he say T1 is what?
T1 is 2 seconds and T2 is 4 seconds.
All right, this is 2, and this is 4. And what's the height?
They're both A. I mean, they're both 1.
Okay, you're going to like this one. It really, on this one, it doesn't matter. I'm not going to flip this second one with 4, okay? I'm going to leave that unflipped. So I'm going to go ahead and draw this here. And this is going to be my H of tau. And it's going to go out to 4. It's got a height of 1. Now I come down here and I do the deal where I first flip. So it starts here, comes here, and then I add that t to it. So here, I have t, and this point is t minus 2. That's the width, still of height 1. Do you all agree? Really the region of overlap is right here, right? It's these two. The product of this times this is just 1, isn't it? Right? So when I look at that, I can say since the product's 1, really what I'm integrating is 1 d tau, right? From 0 to t. Does everybody see that? This is an easy one. So I can just put this over here. I can say, therefore, my y of t being equal to the integral of x of tau times h of t minus tau d tau really boils down to 1 integrated from 0 to t d tau, or it's simply tau from 0 to t, or it's simply what? T. Isn't it, class? Do you all agree with that? Now keep going on this one. When is this valid? For t greater than 0, less than 2, right? From 0, greater than t, less than 2. What happens when t is greater than 2? And you see this, I'm sure. I'm going to draw it right here. Now when t is greater than 2, I have this, don't I? Right? It would be t greater than 2, but less than 4. Right. It has to be right in here, right? It can't be greater than 4 because then part of this region would be outside the area of overlap, the region of overlap. Do you agree with me, class? Isn't that a constant area? How many see that? If this is submerged in that one, both have height 1, it's really the width of this one times the height. Isn't that the area? Which is what? 2 times 1 is?
2.
Yeah. So now you say y of t is equal to 2, right? For t greater than, you better put greater than 2, less than, or equal to 4, right? How many say that? You asked me. Do y'all see? No? Yeah, because look, this one's got a width of 2, correct? This one has a width of 4. Maybe I should have expanded it more. Call it like this so you can see. Now this thing's submerged in here, right? The area of overlap, when you multiply the first times the second, the area is always the same, isn't it, when you integrate? You all see that? So it's a constant. It stays a constant of 2 until you get what? T greater than 4 and less than, people? 6, right? With me? So now what's happened? Now I'm out here. Now I have something where I have this going on. I have t here, t minus 2 here, and you see the area of overlap is this, right? You have to multiply this times this and integrate it. Don't you, class? You see it down here, everyone? You got this one, right?
Yeah.
All right, well, what is it? Y of t would be what? People? Think about it. Where do we integrate from? People? We got a value of 1, right? This times this is still 1, correct? Where do we start our integration? People? T minus 2, right? T minus 2. Where do we stop? 4. You all see that? Not t, but 4, because this times 0 is 0, correct? Everybody see that? Give me a show of hands. Make sure I do. Yes, I know. Jeff, do you see it? Is it my handwriting or? Couldn't likely. So to 4, and it's simply d tau, right? What's this going to be, people? Well, tau integrate, d tau integrate is tau. So now I got what? 4 minus quantity t minus 2, don't I? Isn't that right? And what's that going to be? That's 4 minus a minus 2, or 6 minus t. And this is for t greater than 4, less than 6. That's y of t, the convolution. What's y of t here for t greater than 6?
0.
Y'all see that? It's 0? Show of hands here. I want to make sure everybody sees this. You got that? That's called a boxcar thing. It's two boxcars that you're convolving. And when you draw that, you're going to see something interesting. You'll notice the width is the sum of these two. All the way from 0 to 6, we have non-zero values of the convolution. Do you all see that? The other thing is it's symmetric. When you draw this, actually plot the convolution, y of t versus t. You get this. And it'll look, and this will be 2 right there. It's 2. You all see that? That's the way it'll look. Other problems with convolution? There's some good ones. I got one for you. I think I gave you what, about seven solid problems, right? 7 or 8 solid problems that challenge you, both mathematically stated and graphically stated convolution. I got a few for you, and I want to do them in class. See how you fare with this. This is my challenge to you.
Do the intervals, do they just move by the width of the second?
You really have to look carefully. There's always going to be something from one time to another. It's going to have a certain value because of actually the multiplicative product is behaving one way. Then you get outside that range and all of a sudden it may have a constant value or something like that. But you really got to be careful to look at the entire integral as it's developing and see where there's obvious changes and breaks. Usually it's at the bounds. Where,
Well, I mean like from like 0 to 2 and then 2
right,
to
because
4,
the smallest width was 2. If you have 2 finite width functions, usually you get changes for every interval of width of the smallest width of t1 if t1 is the smallest width. Then the next, there's going to be a change in the actual shape of the output after that. It won't be the same. And it's true there, basically, isn't it? Yeah. Every 2 seconds it's changing. So here's a challenge before we move into the next topic, which is Laplace transforms. We're going to basically get out of this chapter, but I didn't even touch discrete convolution yet, or discrete methods, but we will. So now we talk about this. If I have 2 functions, my first function is going to be this. This is x of t. And my second function is going to be this. I give these problems. All right. And I ask for the convolution of x of t and h of t. Now this is one of those you've got to be focused. You won't get it being casual. You've got to be focused. And you think about the definition of convolution. Convolution, it says, if I convolve these 2 things and call them y of t, that's the integral from minus infinity to infinity of x of tau times h of t minus tau d tau, or vice versa. Or h of tau times x of t minus tau d tau, correct? Either one. So you look at those 2, and which one do you want to leave alone, and which one do you want to flip? And I'll tell you my preference. Are you ready? Now you see the one that's solely in negative time here, where it's non-zero? I leave that one alone. Because when I flip that, it goes here, and then I have to start really thinking hard about which way it's moving when I add that time shift to it. So I'm going to leave that one alone. And we're just going to right here call this h of tau. This is going to be left alone. Got me? That one I don't flip. Now I look at the other function, and before I do anything, I'm going to call this my x of tau here. And I'm just going to have x of minus tau, just so I get my head on straight. So I put x of minus tau here. You don't have to do it this way, but it's helpful. So x of minus tau would start at minus 2 into minus 1 and have a height of 2, wouldn't it? Please make sure you see this. You know what, I gotta move this backward. Sorry. Are you with me, class? This is still versus tau. This is still versus tau. Now just look at this before I do anything more. This would be when the added term t is 0 in that argument. Do you all see that? It's going to be an x of t minus tau here, isn't it? At t equals 0, this is what it looks like. Do you notice there's already a lot of overlap? How many see that? Now I've got this entire function overlapping that entire function already, don't I, class? How many see that? I don't want that, so I'm going to want to move this thing back. So now I'm going to put a t in here, just listen to me. I'm going to put t minus tau here, right? And now I'm going to move this back. Just listen to me. It has a width of 1. I'm going to move it to here. But you noticed I moved it this way, right? That means t is going to be negative. Positive t moves it that way, negative t moves it this way. How far am I going to move it? Now I'm going to start my integration at t greater than minus 1. Follow me? At t equals minus 1, when this is minus 1, now this is what this function looks like. See, isn't it, class? Everybody with me? When t is minus 1, that's what the function looks like. If you were to graph x of minus 1 minus tau, that's what you get, isn't it? With me? So now I'm going to let that thing go. And now you can see there's going to be overlap, right? Now this point here, whatever this point is going to be what? T minus 1. Isn't it, class? It's still got a width of 1, correct? But now for t from minus 1 up to what? Up to 0. Pardon. Yeah, from minus 1 is 0. Now what happens now? Take a look at this. Remember, at minus 1, basically now there's just starting to be overlap, right? Now it's moving in, and then when it hits 0, all of a sudden, everything is overlapped. Isn't it, class? Right? You got a constant, and it's going to stay a constant until I hit 1. Correct, class? Are you with me? And then, from 1 to 2, it's going to monotonically decrease until it hits 0, right? At 2. How many see that? That's a good problem. And it's a challenging problem. Now, I don't know, did I have the actual, did I send you that link that has the graphical convolution link for JavaScripting? It's actually, did you get that? You got it? Who else got that? Was it on the actual webpage or on OneNote?
It just took me to the internet, like.
I did have a link there, right?
Yeah.
I put a link there, and just listen to me. This is a godsend. It allows you to literally graph two functions, then hit convolve, and it'll convolve them for you, and it'll show you the output. It's really cool. I don't think I can get it on there right now. What's the link, by the way?
The simulation of convolution.
Can you give me 4 or 5 extra minutes for me to show you this right here? You'll like this. This will save you your life. You'll save your life. I'll show you this. I've got about 2 minutes left in the class technically, but I want to show you this. It's Friday. I'm trying to be fair and honest with you. I know a lot of professors don't do problems. If you don't do problems here, you're killing yourself. That's my take on this. I'm going to put down the screen and try to show you over here. Try. See how it goes.
While you're setting that up, you mentioned last time to remind you to explain causality.
Yeah, well,
That's gonna have to
maybe
be
causality
next
next
time.
time. I
I'll
mean,
try to remind you
convolution is
again.
hard. Doing these problems for you guys is it'll save you, trust me.
I'll remind you again at the
Thursday.
next. Yeah.
All right, let's see. Start system. I want to show you this for one reason. Most of you, you're visual, if you see how the convolution integral is set up, or actually the two functions are being set up and how they overlap, you can do the integration. But seeing that is hard. So watch this. You're going to like this. Hopefully. So I can get on. Tell me it works. Tell me it works. Let's see another. Is there an HDMI input? Well, it says PC. How about PC? Give me 1 second. Is it supposed to ring?
Would it be easier to just look at this?
I
With the
can't cast
HDMI?
it. I can't cast it. That's the problem.
Oh, I thought they had the.
It's coming up. Thank you. Press.
Escape for startup menu.
Hit that a few times. See, I'm used to just coming down and I got an HDMI plug, just plugging it in. For whatever reason, I don't see an HDMI feed here.
That would make it too easy.
Now, I need you to do me a favor, you're gonna have to read me that down. Hold on for 1 second. Come on down. Please bear, I know you're anxious, just bear with me each word. Have you ever ended up talking to your computer at night?
More like yelling.
I have a discussion. What have I done? Now this Siri thing is funny. You know what I'm talking about?
Yeah.
There's what, Siri, there's a couple other ones. You can get them talking to each other. I didn't know that, you can. Yes, ask one question, get the other one to listen. And then they start talking. I don't know you that way. Really? How do you you know what I'm talking about, anybody?
Yeah.
It asks you these questions. It's like, this is artificial intelligence going around.
I realized it afterward.
Where is it? Find it. There ain't no HDMI. That's the problem. Everybody's.
Is it not plugged into the?
There's no HDMI. Is what we're
It's
trying
plugged
to
in.
tell you.
It's logged in now.
Don't mess around with that. I'll tell you what, class, I'll send you the link.
It's on now.
Well,
The app.
just give me the link. Everybody, it's come. I'm going to show you this right now. All right, hold on. What is it? Hold on. Forget it. I'll send you guys.